I think that we can start with our next session. Actually, it's going to be me who's going to start this session. So, again, my name is Vladan. I'm from Studio Present, and this is the project that we did with our dear colleagues from .lab. The project is called Smart Academy. What is Smart Academy? I will tell you all about it like in 6.5 minutes. So, this is a decoupled Drupal 8 Internet of Things project. We love Internet of Things here at .lab and Studio Present, right? So, the Smart Academy project is a kind of home automation system which is going to be set up at the football academy, which is being built right now in the near town of Bačka Topola. Just like in football, we had a great team and a great formation. We had a few designers working on the design of the application, of the web application. We had the back-end developers, front-end developers, project managers, all working together to create an easy experience for both users of the app and the administrators that are going to use the app at the Football Academy. Of course, we also had hardware engineers at .lab who created controllers which went into the lighting setup, in the heating setup, in the air conditioning systems, into doors and windows. I will tell you all about it in a minute. This is how the app looks like. I'm sorry that it's in Serbian, but I'll explain it to you. So on the left, users of the app in the hotel rooms in that football academy. There are rooms which are used by students, kids who are attending the football academy, and they can control their temperature on the left, and they can turn on or turn off heating or cooling. It depends whether it's summer or winter. In the middle, they can control the lighting in the room. They can turn it on, they can turn it off. They have the notifications at the bottom. They can receive notifications from their managers, from their teachers, about their next lesson, or either their next football training or their next game. There is also a SOS button, which is used by students if they need any help or if something bad happens. The administrator of the app is notified immediately of the problem in that particular room. You will see how the administrator panel looks like in the next slide, I think. This tablet app is also in the conference rooms of the Smart Academy, of the Football Academy, sorry. And there are shades controllers by which you can turn on or, put up or put down the shades on the windows. This is how the tablet looks like in the rooms which are used by the kids. As you can see, it's like a 7-inch tablet mounted on the wall all the time, and it shows real-time information on the tablet. Drupal, in the whole story, is actually here. The Drupal is the administration dashboard of this particular app. So, in this dashboard, the administrator of the app can see everything that's happening in the football academy. For example, in this first square, there are rooms of the kids. And you can see whether the lights are turned on, the windows are open, whether the heating is turned on or turned off. On the right, there is a building log which shows all the changes that happen in the football academy. For example, if somebody left the door open for more than 15 minutes, if somebody is having the AC turned on even if the window is open or something like that. this is how the rooms look like. So just a classic like hotel room used by the kids. And I have a few videos to show you how this works. So, for example, a person can control the lighting in their room by using the tablet, which is mounted on the wall, actually. And every action which is recorded by the app is automatically shown in the Drupal dashboard. You will see it in a second. You see how the lightning bulb turns off and turns on. You can also use it not by the tablet, by using the dashboard app. You can turn on all lights in the building, or you can turn off all lights in the building. You can lock all the doors. You can do pretty much anything that you can imagine in this football academy just by using the app or using the dashboard Drupal app. So this is open for any future development, which will maybe allow, and the client actually is working on that, to allow us to control more things. For example, parking ramps, or the lights at the football fields, or just anything you can imagine, you can control it by using the app like this. This is something that we call master control, and by using the bulk operation model, we are turning off all the lights at once in the whole building. That's pretty amazing. There's another video. Sorry that it's maybe not visible, but my colleague is turning on all the lights from the outside, and he's pretty excited about it. Of course, this solution is cool because it can be used not only by schools like this. It can be used by hotels. It can be used by private investors who want to build something like this for their own home. We all know that we have light automation system like Philips Hue, or maybe we have heating systems, but we do not have a system which combines them all into one at the economic price. I mean, maybe there is a solution, but it's pretty darn expensive, I think. So how this all works will be explained by my colleague. First, Goran, who is going to talk about the back-end part of the whole system, how Drupal communicates with the React app. And then Atila will talk to you about how React works in the app. Goran?
Hi, my name is Goran Nikolovsky. I work as a backend developer at Studio Present. We heard from Vladan what Smart Academy is, and now let's see how it is built. At least we will see now how the backend side of this application works. So Studio Present is primarily a Drupal agency. We love and enjoy working with Drupal, so choosing Drupal 8 for the backend side of this application was a no-brainer. Also, project requirements made Drupal a perfect fit in this case. So, as you can see on the chart, Smart Academy is a fully decoupled system, but it is also a progressively decoupled system. What does this mean? As you can see on the picture, mobile application that students are using is fully decoupled. This is an Android application that is installed on tablets, so it has to be fully decoupled from Drupal. But on the other hand, administrators are logging into Drupal, where they can see dashboards, they can control the system, and this is progressively decoupled system. So at the same time, this is both fully decoupled and progressively decoupled system. This is our second decoupled project, so we are still in the process of finding the best way to handle these kind of projects. We are still trying to work out what is the best approach when we are working on these kind of projects. And when we started working on this, the only thing that was sure was that we are using Drupal 8. Everything else was unclear to us. What modules should we use, how to build the front-end application, what frameworks to use, everything was unclear. So let's see how we are using Drupal. Drupal is used as a data storage system. We are using Drupal to store data. Drupal is also used to place the administrator panels. These panels are built in React and they're placed inside custom blocks. So this is why this is in a part progressively decoupled system. We have a Drupal team, we have custom Drupal blocks, and inside these blocks we have placed components that are built in React. So when we started working on this, we weren't sure how to build the API that will be between Drupal and application. We had several options. We could choose REST that is built in core, JSON API module, and GraphQL module. We really wanted to use the GraphQL module, but it was still in the alpha stage, so we decided not to use it. And in the end, after much debate, we decided to create some kind of hybrid solution. I'm not familiar with all the details and nuances of this system, but my colleague Sensi, who will speak after me, can tell you a bit more about it. But basically, we created a middle layer that is between Drupal and application. This middle layer is built with Node.js, and it acts as a GraphQL server. So as far as Drupal is concerned, we are using core REST endpoints. We have 3 types of endpoints. We have entity routes for doing CRUD operations on entities. We have several views for querying and filtering entities. And we have custom REST plugins for specific things like configuration. So in another project that we started last month, we are using a GraphQL module that now has a release candidate version. So this is a great opportunity to see which solution will work better. This custom approach where we have a middle layer, or is it better to use Drupal's GraphQL module? Working on a fully decoupled system means a little less work on the backend side. At least that is how I feel. So majority of our backend code is consisted of custom entities, of custom REST plugins, and different configuration files. There is nothing else that is really interesting. We decided to use custom entities to benefit from improved speed. Because as you know, when you create a custom entity, you can define all your fields as base fields, then you have all the fields in the same table. This means that when you want to fetch a data, Drupal doesn't have to perform a number of SQL joins. So this is one optimization that improves the efficiency of the application. There is a lot of data that is coming in Drupal, so we had to think about that. And basically there is only one more thing that I want to mention on the backend side, and that is tests. We have PHP unit tests for Drupal side, and we are using Frisbee.js to test REST endpoints. So all our endpoints have test coverage, and this means that we can refactor our code without worrying that we will break something. And basically, that is all that is happening on the Drupal side. There is nothing else that I could say. So I will let my colleague, Mr. Sensi, tell you about hardware and the mobile application.
Thank you, Goran. Hello, everyone. I'm Atila Sensi. I describe you everything which is not Drupal because I'm completely to Drupal compared to Goran. We have controllers, physical hardware electronics, which developed by our colleagues, which are connected to MQTT broker, and we have also some caching, Redis, Drupal, of course, and Influx database for data storing. And we have one more part. This is the application, which is managed by over-the-air update service, which depends on Cassandra database. And at the middle, Node.js services, which connects everything together to get good performance. Now I speak about controllers. We drove the whole electronic schematics and soldered, and everything is done in our office. Here you can see how the soldering part is going. We use hot air soldering technique to put everything on its place. That is, we developed two kinds of controllers. One called main controller. Every place, room, have its own main controller, and maybe have an additional controller called air conditioning unit controller. This is small electronics which is put into air conditioning unit, and it makes it smarter. We use a traditional air conditioning unit, and we just put this electronics in, and we get a smart air conditioning controller. Both controller is based on Espressif ESP32 microcontroller, which sounds like compared to one i7 CPU, weak, but it's very powerful. It has 2 cores, built-in Bluetooth, Wi-Fi, Ethernet, and every firmware is based on RTOS, real-time operating system. Main controller. Every main controller has 8 inputs for sensors, 8 outputs, infrared interface to simulate a controller to control, for example, television, and RS485 interface to put additional electronics like air conditioning controller as a slave to our main controller. We have a contactless current measurement interface, so we can measure the current usage of the room without connecting directly to the cables. And we have also a Wiegand interface for standard RFID card readers. And we have an AC controller, which acts like a master. It can connect to network or connects to master controller as slave. And it has relay outputs or infrared outputs for newer versions of this air control unit. And we have also sensor inputs and general purpose inputs. For example, motion detector. When is no presence in room, then it turns off the unit, or when its window is open, then also turn off the unit. MQTT. MQTT is a message queuing telemetry transport. It's used in IoT. It is publish subscribe based protocol. Its benefit is really lightweight. A minimal MQTT message is only 2 bytes. It has built-in quality of service, which means protocol is a guarantee for the message transfer. And we have also retain message. For example, when server gives message to controller and the controller is offline, this message stays in broker and the controller is going online, it sends to the controller this message. And it also have one cool feature which I really like, that's last wheel. This is when we define what happens if our controller is going offline. For example, when a controller is offline more than half minutes, then our MQTT server is sending to Drupal one message that this controller is offline and needs to do something with it. Maybe it's broken or something like that. And this is my favorite part, which I really enjoy. This is the GraphQL layer of the story. What is GraphQL? GraphQL is basically a syntax which describes how do you ask for data. It lets a client to specify what data it needs. It makes easier to aggregate data for more sources like Drupal, Redis, or logging. And it uses a type system to describe data. It has 3 operations: queries like REST GET, mutations like patch, patch delete, and my favorite is subscriptions that used to push real-time information to the client. So server puts via WebSocket data to clients, not a client asking for data. This is how oops, it's not looking good. This is how an example query looks like. We ask for name, or for a Boolean value is admin, and server returns name, and this value what we want, nothing else. Or if we, for example, delete this is admin line, the server only returns name. And there is no overhead or something like that, just what we need. And this is how the GraphQL works. GraphQL is only one endpoint, so we don't need to look at the documentation or ask the backend developer, hey, what is the endpoint of this entity? We just look at the available queries in our development interface, and React application or React Native mobile application asking the GraphQL server, and GraphQL server returns data from Drupal, Redis, or Influx based on query. Redis. Redis is an open source in-memory key value data storage. It is really easy to use. It has on-disk persistence, which means that when we shut down the server, it writes data to hard disk every 5 minutes and returns it back to memory when we start again the service. It also has a messaging. It also acts as a messaging broker, which we used for real-time subscriptions at the GraphQL, and it's incredibly fast. Our entry-level server, which we use at this project, can done 140,000 requests in a second, which is really good. And for example, if we ask 50 entities for places, it can return in 2 milliseconds request, which I think is really fast. And we use Influx database because in IoT we have really big sensor data. We're logging every entry, every change, and I think it will kill the MySQL in a month. And we needed to solve this problem. InfluxDB is a time series NoSQL database, which means there are no ID. The time is the ID, the timestamp. It's easy to use. It's syntax like SQL. It's automatically done sampling data to lower resolutions. For example, we're logging a data of energy usage for 1 year, and after 1 year, we only want to have the past year's data. We don't need every day's usage, and it's done automatically. It has retention policies. For example, delete this data after half year, which we not needed, and it's ideal for storing sensor data. It has really good compression and powerful add-ons, and it's designed for a very large amount of data. We put many millions of entries in Influx, and it stays fast after that. React Native. Our application is developed in React Native. Why we choose React Native? It's 99% cross-platform. What is that 1%? We have one part which we need to do natively in Java and Swift. This is a module which finds a wireless network and connects to it. And this we need to do separately. Anything else, it's one code. And React Native is not a React.js. React Native is compiling that code into native code. For example, if we put a text tag in React Native, it compiles to something like Android text, and I don't know what is called in Swift. And this has a native close performance. We, at the academy, using the cheapest tablets, and it has really good performance. And UI is data-driven, which means we get data and we don't set states and wait for response. When the response is there, we then render the component with the data. It has a really good developer experience, and it's fast. And as I said, what cannot be implemented in JavaScript, it can be implemented in native languages. And we have over-the-air updates, which is really important for us, because we have built-in tablets in Wall, and we cannot manage every tablet via Google Play, and its network is intranet, so it cannot connect the internet. So we put this new version of application or local server, and we push it to clients without a user. And you are using React Native apps every day, like Facebook, Instagram, Skype, or Tesla if you are rich. And React with GraphQL, I really like this combination. With GraphQL, we get data-driven user interface. So I said, I not rendering an empty component and wait for the response. I render the component with data, and it has two more states, loading and error. And it's really easy to handle that state changes. And we have a really good client library for this called Apollo, which is do a client-side caching itself, and who is work with Drupal REST API. You know this problem. First field of array dot value is the value we need, and we don't have this if we use GraphQL library. And we put an part of application logic to server. So for example, I not comparing time, I just asking for Boolean value to server. Is it master control? Is it in past? And this return from server in a Boolean value, and I do not comparing it in application. And as I said, it's real time. That's it. Thank you.
So if you guys have any questions regarding my part of the presentation, what the Academy is all about, or whether you have questions related to backend or to the hardware, please let us know. We will be glad to answer. Sorry, you need a mic.
Hi, thank you, that was great. Will you post the link to session slides so that we can check the components and links that you used?
Of course. I'll speak to the others in the organization team, but I think that we will post every presentation from today and tomorrow on the website soon. Yes?
Did your client have any issues with consent and amount of control over the lights and all the things happening with the students? Was there a legal side to this, or didn't you have to be bothered by it?
Well, personally, I think that we shouldn't be bothered by that, because that's something that the client would explain to us. But currently, this project is under construction. I mean, our part on the side of Lightning and everything else is done, but the school, Football Academy, isn't starting to work yet. So I guess that the legal stuff will be sorted out when the Academy begins.
Okay, this all looks quite amazing, but what was the most challenging part for you? I mean, for you as a company which created this product, And the other question is, did you have any challenges with security of such a system? Would need to be like not misused?
Well, for me, as someone who designed this dashboard, was a challenge to put this amount of data and the stuff that we can control on a single page. Because we have over 60 rooms, I think, that can be controlled. So that was a challenge on my side, but I think that the engineers had much bigger issues.
Yes, the main problem is security, that we added an additional API just for security. We use Drupal's OAuth module, and that's used authorizing the controllers, the system, the application, and admin, and all of the clients. And this is the most challenging part of the story, because these hardware components are cannot store this amount of data. For example, 2 tokens. This is too much data for this little device, and we need to solve this. And I think we solved that security issue because we are using some transport layer security and that things, and this network is completely physically not connected with the internet. So we can connect to it over just with SSH. And I think security is not a problem in this case, because this is locally not. Everything is done in local.
So you used a lot of tools and new things. How much time did you spend on building it, and how many developers were you?
We spent 4 months to develop this. We have one hardware engineer. I'm done this GraphQL and JavaScript things, and we have, I think, 2 backend developers, designers, and 1 front-end developer. So we 6, 7 on this project in 4 months. But we work really, really much, and on weekends, and we spend every our time on this project.
And I would just like to add that this is much a never-ending project, you know, because the client will always strive for more stuff to be more automated, you know, because now it has lighting, heating, Windows doors, but in the future, who knows?
Will any bit of parts that you've done in developing this technology be open sourced?
I am a Linux and open source fanboy, so everything which use I think is open source in this project. Influx, Redis, GraphQL is open source too, React Native, Drupal, of course. So I think we don't have nothing which is not open source. And this over-the-air update 7 is open source too, because this over-the-air update just a copy of Microsoft's code push, which is for pushing over-the-air updates, just open source, and we use this because I don't like this closed source things.
Okay, so all the components are open source, but how you used it, will that be documented, and will that also become open source? So we can use that as well?
This is a really good question. Will be one part, yes. Maybe it will be open source too, but I don't have these plans now because I'm happy to because it works, and I don't have time to do this kind of stuff.
First of all, I want to just say good job. I really like it.
Thank you.
And how will you manage future options? Like client will request some additional things, and did you leave the space to add something new?
Of course, we develop system to do extensions for that, and I think we have a really good deployment tools and really well-structured code to extend these options. And we can, for example, every moment just develop the new hardware for a new thing, and we put in the system. So I think everything can be added to system. Nothing is nothing is impossible. That's it.
Well, thank you so much, guys. I would also just add that this project is just a proof that Drupal is very open to any kind of automation and any other Internet of Things. So guys from .lab are also doing smart irrigation systems. Maybe we can do a lot more with other smart systems. Maybe we can, not we, but maybe we can build systems for hotels, private houses, who knows. So that's why Drupal is a great platform for this kind of stuff. Thank you.